Hi and welcome to this screencast about JBoss Data Grid security. But first, we're gonna briefly cover what a data grid is. A data grid is an in-memory distributed data store designed for fast access to large data volumes and scalability. JBoss Data Grid comes in two different modes. The first one is called client server, and that means that the application and the data grid are running in separate processes, and the data grid can scale independently of the application, and different applications can access the same data grid remotely over network calls. The second mode is called library mode, and means that the application and the data grid are sharing memory, giving superior performance for accessing data. The drawback is, however, that the data grid has to scale together with the application. You can also alternatively have a backup storage for both these modes, so that data are also kept on disk, for example, or in a database. Some common data grid use cases are, for example, cloud and big data, where we want to be able to scale the data store almost indefinitely, but also things like microservices architecture, where application in itself should rarely have states, and the state can then be kept in something like a data grid, and giving possibility to share data between different applications, like for example a user profile that has to be shared among many services in microservices architecture. Another use case is Internet of Things, where different devices are updating the data grid with different events, and then applications can then listen to these events and react accordingly. One thing that are often overlooked in these use cases are security. Some common security concerns in these use cases are, for example, how to make sure that only approved systems or people can access the data, but also how can we make sure that only approved systems and people can update the data. And finally, how do we secure the cluster traffic? In this screencast, we're going to look at how JBoss Data Grid can help with these security concerns to make sure that you have a secure system with secure data storage. But first, let's talk about some basic security concepts. When talking about users here, a user can be both a person or another system. And users are authenticated, and authentication is a process of making sure that users are who they claim to be. Users can also be authorized, and that the authorization is a process of making sure that authenticated users have sufficient access right. There's also a concept called role-based access control, where we map users' given roles to different access rights like read and write. The first step in securing a data grid are typically to secure the endpoints. An endpoint is an access point for connecting to the data grid. JBoss Data Grid supports multiple endpoints, but Hot Rod and REST are the endpoints that support authentication and authorization. Hot Rods and RESTs also support using encryption technologies to secure the traffic. Let's investigate that a bit closer. So we're going to look at a demo where we have a phone book application running inside JBoss EAP and using Hot Rod to connect to the JBoss Data Grid and to access the data. And we need to secure the communication between the app server and the data grid, basically securing the endpoints. Here we can see the application running when we're currently not connected to the data grid. So let's connect to the data grid, and we're going to connect using no authentication initially. So that means that we're not authenticated at all. We're just connecting to a server running on a port called on a specific port with an undefined user, and it currently has 0 entries. So let's generate some entries here. So now we have some entries in our phone book. So we can generate entries and we can clear entries from the cache. So what we're doing here is manipulating the data in the data grid. We're generating data, we can be writing data to the data grid, and by clearing, we're removing data from the data grid. Let's now disconnect from this data grid and connect using a clear text authentication. That means that we will send username and password to authenticate, but we're going to use it in clear text for the moment. So I have a username and password here, and users are stored locally in the data grid in this case. So this is another data grid than the other one, so this one doesn't have any content. It's running on a different port, and now we can see that we authenticated with clear text authentication using the user writer. We can generate entries here as well, and we can clear entries. But what if somebody could eavesdrop on our network communication? Well, let's see how that would look like. So I start a package sniffer and listening to this port, the port of the server, and we're gonna see how the communication looks like. So go back to the application and now do a clear text authentication again and go back to the package sniffer. We'll stop it and then go through. So somewhere around, initially some handshakes, but then somewhere around number 9 we can see that the username and the password is sent in clear text. So that's of course not optimal. So anybody can sniff on the network, they can actually get hold of our credentials. And so how can we secure that? Well, let's restart the package sniffer, and this time instead use something called digest, which is where we encrypt the credentials for the authentication. So same thing again, we now have it encrypted to the same port, same user, and now when we look into these packages, so package 9 is some additional handshake information telling it to encrypt it, and here we can see that we have the server is telling us how to encrypt the credentials, and here we can see the actual request. So the username writer, but the password is not in clear text anymore. So also, if we look into the content, because we only encrypted the password, we will actually still see the content. So we can see the content going back and forth between the client and the server. So for example, we see a person called Sandy Rains here with an email, etc. That's exactly what we'll see on the web page as well. So somebody eavesdropping can still see the content going back and forth. So to help with that, we can also have a similar server that has encryption enabled. So we're going to connect to another port and we're going to start that one. And now if we connect and we select encrypt all communications instead and generate some entries, and then go back to our package sniffer, we will see that the communication, there are some metadata around hard drive, but the communication in itself now doesn't make any sense. It's all encrypted. So not only the authentication, but also the content going back and forward are encrypted. Now you've seen how we can secure the endpoints and the communication between the client and the server. Moving forward, next step would be to control the access to the data grid. So the JBoss Data Grid has different types of permissions like read, write, execute, listen, and admin, etc. And permissions can be mapped directly to authorized user or to a role of the user, what we call role-based access control. By controlling access to the data, we can make sure that authenticated users or systems are only permitted approved actions. For example, if a user with read permissions connects to the data grid will allow them to read but deny them write access. Here we see the application again. If we connect using, for example, clear text authentication and connect to the grid, we can, and as a user writer, we can generate, meaning we can write to the cache, we can clear the cache and generate entries again. But if we change to another user, a reader, for example, reader who doesn't have access, doesn't have write access, we can now read the entries, but we cannot generate new entries and we cannot clear the cache. The write and read actions are controlled by the server, and if we look at the audit log, we can see that the user reader has been denied write access to the cache but allowed read access. So this way we can have fine-grained control of what actions users can take. So far, all the authentications happen inside JBoss Data Grid, but in many cases you want to avoid storing users locally and instead store them centrally. That's called identity management. So identity management enables management of principals and their associated authentications, authorization and privileges across one or more systems or domains. It's sometimes also referred to as identity and access management. Some common implementations of LDAP, which is the most common used identity management, include Red Hat IDM, OpenLDAP, FreeAPI, Microsoft Active Directory, IBM Tivoli Directory Server, Oracle Internet Directory, 389 Directory Servers, etc. Using JBoss Data Grid, it's fully supported to have an IDM server handling the authentication from the data grid. So in that case, the authentication would still be happening going from the client to the server, but the server will then proxy the request to a central IDM server, as many other application does, and check if the credentials of the user, but also get back the roles that the user has, so it can do the actual authorization. Let's see how that looks like in practice. So here I have a Red Hat identity management solution where I have a user called writer, and connecting using an LDAP authenticator, I can connect using writer. This time we have a different password, so we're going to use a simple password like this, which is stored in the LDAP directory. And now you can see that we connected. This is a new service. We don't have any entries yet, but we can generate entries, and we're now connected using writer, which was authenticated through the identity management solution. The good thing about this is that if centrally the user, for example, changes his password, then so let's set up an easy password here, 123456, and then reset the password. Now the password centrally has been changed. Now if we connect, we're going to have to use the new password, 123456, and we can connect with the new password. If we try to connect with the old password, you will see that we're not allowed to connect. We failed to connect. So now we have secured endpoints, we enabled role-based access control, and we centralized the user administration. But how about the cluster traffic, the traffic in between the nodes? How can we make sure that we have secure communication there as well? by enabling authentication and authorization for nodes, we can make sure that only approved nodes can connect to the cluster. Another good thing is that we can encrypt the traffic in between the different nodes. So we can't eavesdrop on the traffic and therefore record data, etc. So to summarize, JBoss Data Grid includes enterprise features for security, like authentication and authorization, encryption on password or all data transmitted, integrates well with most popular identity management systems, and it also supports Kerberos and SB-Nego for authentication. JBoss Data Grid can also authenticate and authorize nodes and encrypt the traffic between. Thank you for watching this screencast. More information you can find on my blog, blog.thomaskvarnström.com. Thank you and goodbye.